Hey, hello, everybody. Hey, this is going to be help on question of the day 12.1. Question of the day 12.1. Now, this has to do with a particle, a sphere that is dropping through oil. This is the same. This is the same example that is on page 150. Page 150. And the only difference between this example and the question of the day is just slightly different numbers. So from the lecture on week 7, lecture 1, for a model 1, which is proportional, the resistance force is proportional velocity. We ended up with these equations right here, and we're going to end up going back to these. But the problem says a small sphere of mass 2 grams. Okay, so we're going to have a mass here, and it is going to drop down, and this mass is equal to 2 grams. And as it moves, it's going to have a resistance force that's going up, and it's going to have a force of mg going down. Okay, and it's released from rest in a large vessel filled with oil, and it experiences a resistance force proportional to speed. Okay, so this right here means it's going to be BV. That's its resistance force. So I put the negative in there because I'm saying down is positive, and so up is negative. It's going to resist. It is going to resist that. Okay, and it says the sphere reaches terminal velocity of 5 centimeters per second. Okay, 5 centimeters per second is equal to the terminal velocity. Okay, now. If we just think about this sort of quickly from our sum of the forces, the sum of the forces in the y direction would be mg minus bv, which would be equal to ma. Okay, force down is positive. There's the resistance force. It's negative because it's going in the same direction. Equals ma. Now, if this is terminal velocity, that means it's as fast as it can go, that means the acceleration is equal to 0. Now just think about this. If right up here, if our velocity was 0, okay, right when it started, our acceleration would be equal to 9.8. But as it goes faster, it's going to get lower and lower than 9.8 until it reaches to be 0, and that at that point it's equal to terminal velocity. That's going to be equal to mg, and we're going to then say mg is equal to bvt, and if we divide by b, we would get terminal velocity, but this time we want what that b is, and so we're going to have terminal velocity. And this is going to give us the equation for calculating the B value. Okay, so what I'm going to do, and this is very, very slightly different than the book, I'm going to change everything to kind of standard units here. And so my mass here is going to be 0.002 kilograms times 9.8 meters per second squared divided by 0.05 meters per second. Okay, so if you look in the book, they're gonna kind of use the numbers that they gave you, those units, and you guys can kind of see the difference there. So we're gonna go 0.002 times 9.8 divided by 0.05, and we're going to get 0.392. Okay, so our B value is equal to 0.392. And the units there let me see, we've got, this is kilogram meters per second squared divided by meters per second. Those meters going to cancel out. One of those seconds is going to count. So we're end up with kilogram per second. Okay. And that is be the answer for calculating what the B value is, which I'm going to ask you in the question of the day on 12.1. Now the units don't quite make sense, but when you plug it in there, it will end up giving you what you want. So that would be B. So the second value is going to be what is tau? And so if you go back into this, here's the equation that's involving tau. V is equal to Vt times 1 minus E to the negative T over tau. So tau is just simply M over B, and it is the time it takes to reach 63.2% of its terminal velocity. So, and I forgot to do this on the lecture there, but if we're going to graph this and we're going to have velocity versus time, if we were to drop something in there, it is going to slow down. So it would end up looking something like this. All right, and we remember from our sloperometer, okay, if we were to take the slope right here at time is equal to 0, then that would be 9.8, okay? And as it's sped up, okay, it's going to get lower and lower and lower until we reached this point right here. Okay, and so this is going to essentially close in asymptotically, and this would be our terminal velocity. So our value here, okay, would be 63.2%. Okay, whatever this value is, that is equal to tau, and that would give us what that value is. So when we're calculating tau, we just want to do M over B, which our mass is 0.002 kilograms, divided by B, which is 0.392 kilograms per second. And if we calculate that out, we're going to end up 0.0051. Okay, so our tau value is 0.0051 seconds. Okay, so this is essentially the equivalent of part 2 or part B of your question of the day for 12.1. All obviously different numbers here. So it basically is going to take 0.0051 seconds to reach 63.2% of its terminal velocity. So the last part in this question is it's asking you how long does it take to reach 90% of its terminal velocity. So whatever we figure out here, it should be greater than 0.0051. Okay, and in the question of the day for 12.1, I'm asking you how long does it take to reach 50% of its terminal velocity. Okay, so I'm going to move this over to here where we have more of our more space here. So we want to know what the time is. What is the time it takes to reach 90% of our terminal velocity? So I'm going to use this equation. V is equal to Vt times 1 minus e to the negative t over tau. Okay, now we know that this is 5 centimeters. We know this is 5 centimeters per second, but I'm not even going to do it that way. I'm going to say 0.9 Vt. Okay, so 90% of Vt is going to equal to Vt times 1 minus e to the negative t over, and our tau value was 0.0051. 0.0051. Okay, now, sorry about that. So we know that VT, okay, we know that VT and VT are going to cancel each other out. So we're going to end up with 0.9, okay, is equal to 1 minus e to the negative t over 0.0051, okay? And so what I'm going to do is I'm going to subtract 1 from both sides, okay? And 0.9 minus 1 is going to be negative 0.1, okay? And that's equal to negative e to the negative t over 0.0051, okay? This negative and this negative will cancel out. Now, how do we get rid of this e? Is we're going to take the natural log, and we're going to take the natural log of both sides. So we want the natural log of 0.1, and we're going to get negative 2.3. So we're going to get negative 2.3 is equal to negative t over 0.0051, okay? And now this negative and this negative cancels out, and we're going to multiply both sides by 0.0051, and that is going to give us t. And when we talk about that, times 0.0051, okay, we end up with 2.3 times 0.0051. We're at 0.0001. 0.001. 17 seconds. Sorry, I got too many zeros. Okay, 0.0. Okay, so this right here would be the equivalent of 11.7 microseconds is equal to the time. Now this 0.0117 seconds would certainly be suffice as far as the time. Okay, so the first thing that I asked here is what was this coefficient, what was tau, and how long it took to reach 90% of its terminal velocity. So your question of the day is going to be just like this, except there's going to be different numbers. Okay, hopefully that helped. See you next time.